For this lesson, let's talk about algebraic terms. So whenever we talk about terms in math, usually we talk about fractions. And so the term, we would say the denominator or the term in the numerator. But in algebra, the word term is going to be for a part of an algebraic expression or an equation. So it can have 1, 2, 3, or more terms. So I am going to say a monomial, this type of expression, monomial, only has one term. Here is a chart, number of terms, 1. And here's an example. So a monomial can be negative 6x. That has only one term. A binomial has two terms, right? And so we can do x squared minus 3b squared. So a binomial, this equation has two terms. And a trinomial has three terms. And this can go on. Has three terms, so let's say 9x squared minus x minus 7. That is a trinomial, so it has three terms. One here, and one here. Okay, so we can, each term has a sign number and can have one or more variables. And the variables are the letters. Sometimes the sign number part isn't written, right? So let's take this trinomial right here. So the 9x squared is we have our super secret ninja 1 is 1, or no, it's not a 1, it's 9, but it's positive, right? So let's actually do, let's look at this one, this x squared, right? So now we have our super secret ninja 1, right? So it's the same as, it's positive, so there's a negative in front of it, 1 x squared. Okay? Because it's the same as if we multiplied 1 times x squared. 1 times anything is itself, so it's still x squared, but we just have to remember that when we're solving these problems sometimes. So for this one right here, it's negative. If it was just negative x, we would still have our super secret ninja 1. It would be negative 1 x squared, because negative 1 times x squared would just give us that negative x squared. So sometimes these numbers aren't written out, right? even though the sign is there. That's why I'm calling it Super Secret Ninja 1, because that number isn't always written out. But that is the, what is it? The coefficient. Am I thinking of the wrong thing? Yeah, that is the coefficient. Might need to check me on that. That's what the number right before a variable or letter, I'm pretty sure is called the coefficient. So not everything needs to have a variable or a letter like this last one here, right? It's just -7. So that number is constant. It's called a constant because it never changes. Like if x on this one, if x is 2, then it would be 2 squared, which is 4. 9 times 4 is 36. So that would change this whole part, right? Since there's not a variable here or a letter like y to multiply it by or anything, it doesn't change. So this would be constant. So constant terms, you just do regular algebra on them. So if you had this 9x squared minus x minus 7 plus 3, you would go ahead and put those two together. So 9x squared minus x minus 4. Okay, so things that are alike can be combined with algebra. So I don't have any examples here. But they have to have the same parts. Like this -6, let me switch here. So I'm gonna write those two out. -6x plus x squared minus 3b squared. These x's are not the same. The exponents have to be the same for you to combine them. But if you had -6x squared plus x squared minus 3b squared, then these exponents are the same, so you can add them. We'll add our super secret ninja 1 here. So -6 plus 1 is -5, and then we'd have the x squared minus 3b squared. So if we had something like -4xy plus xy, we would combine, oops, that looks like a squared. This is supposed to be y. Okay, so these two are the same, right? They also have super secret ninja 1 exponents. But they have like terms. So you can add your super secret ninja 1 here and do -4 plus 1, -3, and leave your x and y. Right? You can combine those. If it had been, if you had y squared here, they would be different. You couldn't combine them. You would have to leave them. So let's try some examples. All right, so let's do simplify. Okay, let's do 4x plus y minus, no, plus x minus y. Okay, we have four like terms here. We have x, 1, 2, then the y's 3 and 4. So we're going to look at these two together. And oops, I thought I changed that color. These two. Okay, so we have 4x, and that's our exponent of 1, super secret ninja 1. It wouldn't be 0 there because that by math rules is equal to 1. So we couldn't do that. It's actually the super secret ninja 1 that we don't always write. Okay, so plus, oh, so now we're looking at this, it's got the plus sign, so plus, and we have a 1 in front that we don't see, the ninja, x, and also 1. Now, I'm doing opposite colors now. Now we have y, and I'm just rearranging by the commutative property, but now we have plus 1, y, 1, minus 1, y1. I'm just adding in the ninja 1s that we don't see, so that we can see what we're adding and subtracting. So that's going to give us 4 plus 1 is 5. We leave our x, you don't have to write the 1, so 5x. So 4x plus x, that's 1x. So we have 5x. We have opposites here, plus negative of the same number, so those are going to cancel out. Because plus 1, y1, minus 1, y1. So our answer for this is just going to be plus 0, 5x plus 0, which is just the 5x. Okay? So now let's do another example. And instead of simplify, I'm just going to say collect the like terms. Since we were talking about algebraic terms for this lesson. So let's do 4x plus 3x squared plus 5 plus x squared minus x minus 1. So let's rearrange this by the commutative property and what the like terms are. Okay, so I'm going to do the x squareds, right? Then we can do the x's, and then we can do the constants. So these don't have variables. I'm going to rewrite this as 3x squared plus our ninja 1 x squared plus, we don't have a positive here because it's first, plus 4x. I'm not going to write the 1 after that. And then we have minus, I will write the 1 here, 1x plus 5 minus 1. Okay, so now this can be rewritten. We're going to go ahead and put these together. So 3 plus 1 is 4x squared. Those are like terms because they have the same exponents. Now we have 4x minus 1x. 4 minus 1 is 3, positive 3, and it's x variable. Now we have 5 plus 5 minus 1. So 5 minus 1 is plus 4. So this is going to give us everything collected. So x squared, this x squared, these can't be combined by addition because they're not like terms, right? So one thing that we do when we're combining like terms with algebra, we put the exponents in order by the largest one being on the left and the constant term with no variables being on the right. So 2 is bigger than our exponent 1 that we're not writing here. So that's why it's first in line, and that's why whenever I wrote this line out, why I had the x squareds first, because in traditional algebra, we put those first whenever we're writing out answers. So whenever we have an expression without this constant, it's understood that 0 is the constant term. So if we had ax squared plus bx, we would just know that the constant is plus 0. Okay, we don't write it out. It's just like another ninja number that we don't always show, right? Just like if we're expanding the number 107, we write 100 plus 0 tens plus 7 ones. We don't always write out this 0. We just write 100 plus 7, right? But sometimes for certain things, we're going to need to remember that there's actually zeros in here and ninja ones. We'll just have to keep that in our mind so that we don't get confused when we're doing algebra. That's all for this lesson. Let me know if you have any questions.